One from example. In today's lecture, we are going to mainly focus on biomaterials and the various categories of biomaterials, and then we are going to discuss about biotechnology. And we are going to correlate the relationship between biomaterials and biotechnology. Before going into this topic, generally we have to discuss what are different type of materials, what are different type of engineering materials, and what is mean by biomaterial. So these are the contents of today's lecture. First we are going to see about the introduction, then we are going to see about what is engineering material, and what are the different type of engineering materials, then we are going to discuss about the classification of biomaterials, and finally we are going to discuss about what are the different biomaterials which are applied in human body, and then we are going to discuss about biotribology and tribological behavior of biomaterials. Mainly in this lecture, we are going to focus about the tribological behavior of artificial and natural biojoints. And as I already discussed, first we are going to discuss what is engineering material and what are the different type of engineering material. First, we should be very clear in this concept. Now, let me give a practical example of what is an engineering material and what are different type of engineering material. We all know, we all are very fond of drinking cool drinks. For example, Coca-Cola or Fanta. This cool drink will be available in three different concepts. One is in glass bottle, and second one is in plastic can, plastic bottle, and finally in an aluminum can. These three are the main example of an engineering material. First one is a glass bottle. Glass is nothing but ceramic. It is one of the major engineering material. Second one is can. It is an aluminum can. It is an example of metal. And third one is plastic bottle. It is an example of plastic. It is particular example of polymer. So these three are the main classification of categories of engineering materials. And finally, there is one term called composite. Composite is nothing but a combination of two or two different materials in order to increase their properties. So here we can see that from this Venn diagram, we can see what is a composite. What are different types of composites? Basically, there are three different types of composites. One is metal matrix composite, that is the metal will be a base element, and the other reinforcement can be either ceramic particle or polymeric particle. That is an example of metal matrix composite. And second one is polymer matrix composite. Here the polymer material will be a base material, and the reinforcement will be either metal powder or a ceramic particle. And third one is ceramic matrix composite. In this ceramic matrix composite, the ceramic material will be formed a base phase or matrix phase, and the reinforcement particles will be either polymer particle or metal particle. So these three are the main classification or main category of engineering materials. So this is the general definition of what engineering materials or materials. Now, on further discussion, we will go on to discuss about what is meant by biomaterial, and what is the definition of a biomaterial, and what are the different classifications of biomaterial. So, basically, what is the definition of a biomaterial? Biomaterial is nothing but a material which is used to develop biotech devices which is being placed in the human body. So this is the classic definition of a biomaterial. As you can see that a biomaterial can be defined as any material which is used to make device to replace a part of the function of the body. The best example is our body implants. For example, if a person is involved in an accident, he gets his hand or leg fractured. We are going to replace that hand by using a plate or implant. That implant we are going to develop using some material. That type of material is called a biomaterial. The best example of the biomaterial is titanium, magnesium, and some other polymers. So common examples including structures, tooth fillings, needles, bone plates, etc. As I said, these are the common areas where the biomaterial is being applied. And the formal definition or the universal accepted definition given by the University Attestation Board states that biomaterial is defined as a systematically and pharmacologically inert substance designed for implantation within or incorporation with living systems. Here, we have to identify what is the pharmacologically inert substance. As we know, inert substance is a substance in which there is no chemical reaction. So, the pharmacologically inert substance means that the material which you are going to use to develop a device that material will not chemically react with any living tissues within the body, or it will not corrode, or it will not get burned. That is called pharmacology in a substance. So this is the basic definition of a biomaterial. So, as I already said, it should be inert one. So, in biomaterial, what we call it as biocompatibility. That is, how the materials are going to use is going to be compatible. It is going to be non-reactive. That is called biocompatibility. So, by the biocompatibility, it is classified into two types. One is the biological reaction with the cells and tissues within the body, and the second one is the biomaterials, the property of the biomaterial. That is how the chemical property, how it is chemically inert, how it is mechanically inert, and how it is how the surface properties, that is wear and total friction. Those all these things comes under biocompatibility. The medical field, the most important property of biocompatibility is that first there is interaction with cells, fat, bones and tissues. Because one can imagine that when you are going to place a material in the body, an artificial material, it should not react with the tissues. If it is going to react with the tissues, that material will get eroded and some degradation will take place. So that is the most important thing, is that the material which you are going to use, which should not react with the tissues or the living organisms within the body. So that is called the place of biocompatibility in nature. Because the ultimate goal of using biomaterials is to improve the human health. By restudying the function of natural living tissues and organs in the body, it is therefore essential to understand the relationship between the properties, functions and structures of biological material. The property of the materials you are going to use, it determines the lifetime in which the impact of the organ and survey. As I already discussed, the major property of the biomaterial which you are going to use is biocompatibility. What is biocompatibility? The biocompatibility is nothing but the ability of the biomaterial to not react with the living tissues, and it should provide proper environment. Now, the biocompatibility is major classified into two categories. One is how the organ is going to interact with the living tissues inside the body, and second one is based on the properties of the biomaterial. What are the properties? One is chemical property, second one is mechanical property, and pharmacological property and surface property. The chemical property is the chemical property which are biochemical processes, the corrosion and degradation. What is corrosion? As we know, we are going to place the body implants in the area in the body where there will be a fluid flow and there will be blood flow, where there will be synovial fluids in the joint. These fluids should not corrode the material, and the material should be retained. That is the major property of biochemical process. And second one is the time-based degradation. That is, since the plate is going to be inside the body for a large amount of time, large amount of years, it should not degrade constantly with respect to time. That is also one of the main property. And then is the mechanical properties. What are the different mechanical properties? That it should have a proper strength, and it should have these are the mechanical properties. And surface properties is nothing but that it should have a very good wear resistance. Because some of the joints, especially knee joints, they are going to have a rotation or movement with respect to each other. When they are going to have a movement with respect to each other, it should not wear. It should not get worn out, and the friction should be very less. So these are some of the important properties or biocompatible nature of the biomaterials. So these are the main things which are material process, so that it is a biocompatible material. First one is it is formalizically inert, and second one it is chemically inert, and then it should process mechanical strength, and it should have fatigue life. What is the use of fatigue life? Since the implant is going to have a movement or a load, it is going to bear the load for a large number of time. It should have a very good fatigue life, so that the fatigue failure does not take place. And the most important thing is proper weight and density. The plate or implant which are going to place inside the body should not have a very high weight. Since if the density is going to be less, normally the weight of the implant will also be lesser, so that it will be a proper, it will be comfortable for the cost factor also should be taken into consideration. So these are the main characteristics of a biomaterial which we should choose, which we should follow before choosing a proper biomaterial. As I said, biocompatibility is one of the major properties. Chemical stability, measurability. What is the need for a measurability? For example, in the knee joints, we are going to place a stem or plate inside the knees. So how many are going to place? We are going to drill a hole and we are going to place inside the body. So the material which we are using, we should have a measurability so that the holes can be easily drilled and it can be placed inside the body. That is the measurability. So these are the important characteristics of a biomaterial which we should use. So these are some of the properties which I already discussed in the previous slide. Okay, now we are going to see what are the different classification of a biomaterial. Already the engineering materials are classified into three types. One is metallic materials, ceramic materials and polymer materials. Similarly, we are going to classify the biomaterials. The biomaterials can be classified into two categories. One is natural biomaterials and another is synthetic biomaterials. What is the difference between a natural biomaterial and a synthetic biomaterial? Natural biomaterial is a material which is going to be made from living organisms or plant or natural things. That is called a natural biomaterial. The best example for a natural biomaterial is silk. We are any mood is taking place, we are going to use silk to heal it. That is the major advantage of that is one of the best examples of a natural biomaterial. So natural biomaterial is being classified into two types. One is protein-based biomaterial, second one is polysaccharide-based biomaterial, and what is synthetic biomaterial? Synthetic biomaterials are man-made biomaterials or biomaterials which is placed in natural pores. One is a metallic-based biomaterial, ceramic-based biomaterial, and synthetic polymer-based biomaterial. Mostly, in the biomaterial industries, metallic alloys are being used. For example, in knee joint, we are going to use the commonly used alloy in the industry is cobalt chromium alloy. This is one type of alloy. So these are synthetic biomaterials which we are going to use in biomaterial sector. So these are the major classification of biomaterials. There are two types. As I discussed, there are two types. One is natural biomaterials, another is synthetic biomaterials. Natural biomaterials are those materials which are derived from the living organisms or plants or animals. Synthetic biomaterials are man-made biomaterials. The most common example is alloys and composites. Okay, these are the classification of biomaterials. Okay, so these are some of the examples prominent biomaterials type of biomaterials which are used in industries, and what is the reason for using them, and what are some of the applications. For example, first category we are going to see is metallic-based biomaterials. In this we are going to use titanium alloy, stainless steel, as I discussed, cobalt chromium alloy. This is most commonly used. Titanium alloy and cobalt chromium alloy, these are the commonly used alloys in metallic biomaterial industries. Magnesium alloy, nickel titanium, this is a super alloy. Okay, these are the what is the reason for using this metallic biomaterial? First one is the mechanical strength and mechanical properties will be very higher as compared to other implants, and it will have a very good tensile strength and compressive stress, etc. What are the area in which this being used is artificial is mainly used in orthopedics. What is orthopedics? Orthopedics is nothing but your knee joint and your shoulder joint. These are not orthopedics, and in this joints, the artificial material which we are going to use mainly composed of metallic biomaterials. Second one is ceramic biomaterials. First we should know what is ceramic. Ceramic is nothing but oxide or metals. This is not in a single state. It should be in a combined state in the form of an oxide or carbon. For example, zirconia. Zirconium is a metal, and zirconia is zirconium oxide. The zirconium metal is in the combined form of oxide. This type of materials are called ceramic materials, and the ceramic materials, the main advantage of ceramic materials is it has very high wear resistance, it has very high mechanical strength. Okay, hydroxide is one of the most commonly used biomaterial ceramic material in the medical industry, and apart from that, biomass, zirconium, alumina, these are some of the ceramic biomaterials which are used in industries. As I said, the main important properties are it has very high wear resistance, it has very high resistance to corrosion, high mechanical strength, hardness. These are the common properties where due to which we are going for the ceramic materials. And these are some of the polymer based materials which are going to, which are used in nowadays. Metallic materials is being replaced by polymer based implants. The main common polymer which are going to use is PLA, polylactic acid, high polyethylene. There are three types of polyethylene: low density LDPE, there is low density polyethylene, high density polyethylene, and ultra high molecular weight WHWFPE. So these are the commonly used polymer based biomaterials in surgical and other biomedical industries. Okay, now in which areas the biomaterial is used in this implants in which parts of the body, different type of the body. What are the common parts of the body in which the biomaterial is being used in the implant in medical sector? So, 95% of the implants, they are using the knee joints and cardiovascular areas like the pacemaker and contact lens, and most importantly, the skin healing issues. For example, if some part of the skin is going down, they are going to replace the skin tissues. Okay, how we are going to, for this replacement of skin tissues, the biomaterial is being commonly used. Okay, for this skin tissues, what are the common materials which are going to use to replace the natural skin tissue? Well, these are the natural implants, cellulose and cellulose and chitosan are the commonly used material in biomedical sector. And synthetic, what is the natural implant is? All these materials, they are derived from plants or human beings. These are naturally they are generated. Whereas in this case of synthetic implants, PCL, PPA, PLA, polylactic acid. This is one of the most commonly used polymer. These are synthetic based materials. These materials are, and composite implant can also be used. There is a combination of two or more different materials. These all materials can be used as skin healing scaffolds for the skin replacement. And second one is cardiac implants. As you know, nowadays many of the deaths are taking place due to the cardiac arrest or cardiac faults or cardiac diseases. How to minimize this? For this, pacemakers are being used nowadays. So the many materials we are using pacemaker are scaffold for the pacemakers are natural biomaterials. These are some of the biomaterials reinforced composites we are going to use for the scaffold preparation for the cardiovascular diseases. Okay, now in the human body, these are the various areas of various applications in which biomaterials are being used. Now let's start from the knee. There is an ankle joint. From the knees to the feet. This area is joint, this ankle joint, and the knee joint, left shoulder joint, cardiac joint, there is hip joint. All this joint, what is the basic description of biomaterials? All these joints, in this the joints we are in natural, all these are natural joints. So what is happening is, as the age progresses, that in these joints there is natural fluid inside the joint. As the age progresses for a person, this fluid will automatically decrease. What is the use of this fluid? Is called as synovial fluid, which we will see in the coming slides. What is the use of this fluid is, this fluid will act as a lubricant and this will reduce the wear of the joints. But once the age of the person increases, most of the elderly people they are suffering from knee joints, knee pain. Okay, what is happening? This is mainly due to the fact that as the age increases, the amount of fluid inside the joint will reduce drastically, which will lead to the high wear. So in this area, we are going to apply the biomaterial to replace the joints. So these are some of the areas, or some of the body areas in which in the human body where biomaterials are being used. Now we are going to go on to the next topic, that is biotechnology. What is first before going into the concept of biotechnology, we should first identify. First we should identify what is tribology. Tribology is nothing but the loss of material or gradual loss of material due to the contact between two surfaces in motion. That is called tribology. Now, with the general info of tribology, now we are going to move into the concept of biotribology. Biotribology is nothing but the application of tribology in biomedical field. That is, we are going to chew a food in the mouth. Due to that, there will be some contact between the teeth and the mouth. That is one form of tribology. What will happen due to biotribology? When suppose let us consider two joints in motion, when there is a movement between the two joints, there will be some contact between the two joints interaction, due to which there will be some real mass loss or real loss, and there will be some friction generated, which will change the entire concept. So this is called biotribology, or the tribology or contact between the two bodies in action. That is called biotribology. Some of the examples of common biotribology in biomedical applications are mouth between the mouth and the tongue, teeth and the feet, and the frictional behavior of two pair. Between the shoe or shoe, I am wearing the shoe and I am moving, there is some friction between the leg and the shoes. That is called biotribology. Now, what are the most common biotribological applications in medical field? One is the natural joint or synovial joint. Now I am having considering to knee joint. We consider two bones and in between the bone there is we will be having a concept called cartilage. What the cartilage is? We will be studying the thin layer of protein which is made up of some liquid and some thin soft porous tissue. This will be present between the two bones, and between this cartilage we will have the synovial fluid. What is the use of synovial fluid is, whenever the knees are in the joint, there is movement in the joint, this fluid will act as a lubricant, and this fluid will reduce the wear and coefficient of friction. This is the synovial joint. As I said, the joint is like a relative sliding between the bony components. The sliding surfaces are commonplace smooth, soft and porous composite material called cartilage, which is composed of proteins, water and water. The thickness of the cartilage generally varies from 0.5 to 1.5 mm in the hands and shoulder joints. Artificial synovial fluid. First, we know what is the use of artificial synovial fluid. As I already mentioned in the previous lecture, as the age of a person increases, the synovial fluid will the amount of synovial fluid will get reduced, due to which there will be wear and tear in the joints. And then you can see that many of the elderly people, they are suffering from joint pains. In order to avoid this, how they are going to interpret the fluid? They have to increase the synovial fluid level. How they are going to increase the synovial fluid level is, they are going to artificially prepare a synovial fluid, and then they are going to present in the implants. Artificial synovial fluid refers to a substance designed to mimic the lubricating properties and functions of the natural synovial fluid found in the joints. Synovial fluid is a viscous slippery substance that helps reduce friction between the surfaces of joint during the movement. So, whenever there is need to improve the synovial fluid level, we are going to prepare artificial synovial fluid. Okay, what are the different compositions of that? So artificial, I said we are going, this is not natural synovial fluid. We are going, the same composition we are going to prepare in an artificial manner. So what are the constituents or what are the components that should be present in it? These are the major, one is this is the major proportional components. This provides the lubrication properties. That is ionic acid. And second is sodium hydroxide, polyethylene glycol, PGA, body sacrifice, proteins, antioxidants and preservatives. What are these? These are the main antioxidants and preservatives are the important thing. Artificial synovial fluid, because this preservatives will help that synovial fluid from getting because whenever they are placed in the body, there will be some debris will be coming from the joint, and this should not contaminate the fluid. And these preservatives will help in ensuring the stability and the longevity of the artificial fluid. It will not allow the contaminants to settle down. Okay, this is an example of knee and hip joint. How the artificial implants are taking place in the knee and hip joint. This is the normal hip joint of a normal person. This is the stem is there, femur is there, and cap is there. But this is as you know, arthritis is one of the most common diseases in elderly people. But this is joint of the person affected with the arthritis. What is happening is we can see a lot of scars. Here you can see that it is all right, but from this diagram you can see that there is a lot of scars and the bone gets hardened. When the bone gets hardened, what will happen is they will not be able to move properly and they will not be able to fold the legs. These are the common things that happen. Now, what are the things we are going to do to eliminate this? So what they are doing is, this part is called stem. This stem part, they are completely replacing it with an artificial implant and then they are placing a polymer-based cap. What the use of this cap is, this cap acts as a bearing. This will transfer the load and it will also rotate. So we are going to place molecular polyethylene cap and this stem will be fully implanted and this will help the person from relieving from the pain. It will act as a new joint. Okay, what are the different types of joints? Mostly our knee and joints are shoulder joints. Everything comes under the ball and socket joint. What is this ball and socket joint mechanism is? There is only one socket. There is the shoulder joint. Here there is some socket. And in the tip of the under end, there will be one ball. This ball will be placed on the edge of the socket and this will form a joint. And the main advantage is there will be rotation in all the three axes. That is their ball and socket joint. This is the hip and shoulder joints. You can see in many of the operation hospitals, we will be having hip operations and joint operations, shoulder joint operations. These are the main artificial joints which are used in medical industry. Apart from that, we have inside saddle joint, ailing joint, pivot joint, and plane joint. These are some of the commonly used joints in medical industry. Okay, what is the friction in biosystems? In the biosystems, the friction can be either high or low. Both it should not be either too high, it should not be too low. Okay, it should be in the medium level. Common example is that in the knee joints, the friction should not be too high. And in the case of hand, we are loading something in a hand using the finger. So this is the example of some of the frictions. Either the friction should not be too high or the friction should not be too low. This friction plays a vital role in the preservation of the function of the components inside the human body. Okay, I think this covers the syllabus.